Hi all, welcome to my channel Java Soul. In today's video, we are going to discuss functional interface. So all functional interface are available in java.util.function package. First, we will discuss predicate functional interface. Let's open this interface and explore this. As you can see, it's available in java.util.function package and it's annotated with the functional interface. Annotation which tells like it's in a functional interface. It is having an abstract method test which accept the single input and returns a boolean value. And also you can see there are some default method and or a negate. We'll see with the program. So I have already created this program. So first we are creating the predicates. Okay, as I told, it's accept as single input. Okay, here and the type of predicates, as you can see, it's an integer, so value will be of type an integer. Okay, we are checking it's an even or not. Here I'm calling the test function. It's there in the predicate, so I'm passing the value. Okay, 4 basically it's an even, so it's returning a true, and 5 is an odd, so it's returning a false. Okay, now see how to filter using predicate from a list. So we do have one list this, and we have created here predicates, and checking the name is starting with the a. Okay, here we are using the streams and calling the filter, and inside filters we are passing these predicates. Okay, we are checking each elements of an stream is starting with the a or not. Whatever is starting with a, it's returning. Okay, now we'll see how to use AND or a negate function. These are the default function. So I have created one more predicates here to check the number is greater than 10 or not. Okay, then creating a one more predicates, okay, using the AND function. So first I'm using each even predicates, then passing each greater than 10 predicates in AND function. Okay, so it will returns a true when both predicates are true. Here I'm passing 12. 12 is even as well as it's greater than 12. 10, sorry. So it's returning a true. Now, in case of 8, one condition will be a false. It's not a greater than 10. So it will return a false. Okay. Now we'll check or. If any one of the predicates is true, it will return true. In case of 8, earlier it was returning false. Now it will return true. For 7, it's not greater than 10 as well as it's not an even number. So it's returning false. Now the use of negate basically to reverse, okay, the output of predicate. Here you can see I'm calling the negate function on each greater than 10 predicates. Okay, I'm passing the 12. Okay, because it's returns a true because this 12 is greater than 10. Okay, now we are calling the negate, so it will reverse the output and it will return a false. Let's see. Okay, so as you can see, this negate is false. Okay, all of these you can see. Now we'll see BiPredicate. So BiPredicates basically takes two inputs, okay, returns a boolean value. So as you can see, I have already created the programs, and let's open this. Okay, as I told you, it accepts two inputs. Okay, and this is also in a function package and annotated with functional interface, and also having the same default method and or a negate. Okay, we'll see with the program. So here you can see I'm creating by predicate. Okay, there are two inputs, and I'm just calling. I'm checking this. The input value is equals to admin or not. First input value, and then second one is the password is equals to password 123. So I'm passing this value inside a test function of predicates. It's returning a true because it's matching, and it's returning false because it's not matching. Okay, the same case is with and or negates, as I already explained in the predicates. Okay, like if both predicates by predicates it's true, then it will return true. Okay, as you can see, this a in first predicates we are checking a is greater than b. So as you can see, the first parameter is greater than second, so it's returning a true. And the second, um, second we are passing two values, 10 and 3. Okay, and you can see we are also checking it's even or not. Okay, and when we are passing this 10 and 3, it will not be even. Okay, even means we are doing a modular with 2. Okay, by doing a minus b, so it's not returning a 0. Now we'll see the third functional interface. Here we will see the functional interface. Okay, then we'll see function. So in let's open this functional interface and explore. It's also in a function package and annotated with @functional interface. Okay, it has one abstract method apply, and it takes an input. Okay, and it returns an output also. Okay, here you can see there are some default methods like and, then, and compose. Okay, and we'll see with the program. What I'm doing here, I'm creating a functional interface. Okay, there is one input. Okay, it's from here I'm returning the length of this string. I'm passing this string here in apply function, and it returning output as a 5, because it's written just in a length. In this case, it's returning a 6. That's it. So now for chaining, I'm creating a two function. Okay, square and double it, and here I'm calling this and then function. So what and then function is does, first it will execute this first functional interface, okay, which is in a square here, then it will execute the second one, the double it. Okay, as you can see, I'm passing the 3. So first it will is square, 3 into 3 is 9. Okay, then it will multiply by 2, then it will be a 18. Okay, in case of compose, so it's just an kind of reverse of and then. So it will first execute the second functional interface, this one, double it. Okay, this will execute this one first, then it will execute this first functional interface square. Okay, so if we are passing the 3 here, means 3 into 2 is 6, and then we are doing a square of 6. 6, that's the, okay, that's why it's returning a 36. Now we'll see another functional interface. Let's see Unary functional interface. Okay, it's a kind of special, functional interface which extends, the functional interface. Okay, in function, basically, the input and output type was different, but in this functional interface, the input value type and output value type will be the same. As you can see, I'm passing value of type integer here. Okay, and the output is also of type in integer. When I'm calling the apply function and passing 5. Okay, see here I have created one unary operator functional interface. We are doing square of a number. Okay, I'm passing 5, and it will returns an integer also. Okay, that means the same type of input, same type of output. Okay, in the second one, we are passing a string. We are doing just converting this string into an uppercase. This will also return an string. Okay, now we'll see the other functional interface. It should be a binary operator functional interface. So earlier we see unary operator, now we'll see binary operator. Okay, so in unary operator it extends functional interface. In binary operator it extends by function. Okay, functional interface. So it takes a two input. Okay, it also extends, the functions. In a function you can see the apply function takes a two input. Okay, and but in case of binary operator, it will take a two input but of the same type, as you can see here. Okay, the type will be the same and the output type will also be the same. Let's see this. As you can see, we are passing the input of type an integers, and we are doing a sum, so it will also returns the integer type output. Here also we are passing an string, and it will returns an um, mm, same type of value will be of an string. Okay, as you can see here. Now we'll see another functional interface, which is in a consumer functional interface. Okay, so this, okay, let's explore this functional interface. It also, as you can see, in a function package and annotated with at the rate functional interface, it is having one methods except which takes an input but does not return any value. Okay, it is having some default methods which is an and then function. Let's see with program. Okay, here I have created one consumer. Okay, what we are doing, we are taking an input and just printing that input. Okay, so uh, and we are passing here the customer ID 2. Okay, as we are calling the accept function. This is the way to create a consumer using the lambda expression. Okay, now we are calling the accept and passing the value, and then it will print a accept to the customer ID 2. Okay, now what we are doing, we have created one list. Okay, and we are doing in some kind of an operation like giving a 10% discounts on each product price. Okay, this is what an consumer we created. Okay, now we are passing this in a consumer in a for each function. As you can see, this for each is accepting in a consumer here. Okay, and it's doing an operation on a each elements of a list, each elements of a consumer. Okay, now we will print this. Okay, I'll show you everything. Okay, so here I have created one consumer s4 and s5. Okay, and we are just printing, and first it will execute the s4 first consumer, then it will execute the second consumer. So first it will execute s4, then s5, and we are passing the hello world. Okay, in chained consumer, so and then basically used to chain a multiple consumer. Let's execute this. As you can see here, in the first input we are expecting to print customer ID. Okay, this is what we were expecting. Now to we wanted to see, the each product price with 10% discount. As you can see here. Okay, this is what with 10% discount, and here we are printing hello world for both. Okay, here for both consumer. Now we'll see the another functional interface y consumer. So in y consumer, it also having a method, abstract method, accept, which takes a two input um, value. Okay, as you can see here. Okay, this is also in the same package. Now, and there is one default method is also and then. Let's say with the program here. So we do have one map. Okay, and this is basically used when we have to work with key value pair. Okay, in all by consumer by predicates used to work with two inputs. Okay, so now I'm calling. So as okay, you can see here I've created a map in a string. I'm using product. Okay, and the value I'm using the stock. So what we wants to do, we wants to update, okay, the map with by doing just a +5 in a stock. Okay, for each product. So just created here by consumer, I'm doing here stock +5 using a product stock dot put. Now I'm passing this by consumer to for each. Okay, we'll do an operation on each. Okay, elements of a map. So now we are going to print this. That's it. Okay, now I've created two y consumer. Okay, and then calling an and then function. So first it will execute the first one, first y consumer, then second y consumer. I'm passing here name and Ritika. So name will be the first value and the Ritika will be a second. So let's execute this. Okay, as you can see this. Okay, we'll see now a next functional interface, which is supplier functional interface. Let's explore this. It is also, as you can see, in function package and annotated with at the rate functional interface. And there is one abstract method says a get. So it does not take any input, but it's return the value. Okay, let's see with the program here. As you can see, I have created one class. It's a user static class inside this producer program. Okay, now what I'm doing, I'm creating an object of a user. Okay, and so the type of the supplier is also a user, as you can see. Okay, now I'm just calling a get function, okay, to get the object from the supplier. That's it. This is the way. So this is basically used in that case when we need output but does not, but we are not going to provide any inputs. That's it. That's it for this video. If you like this video, please subscribe my channel and provide some comments and do like. Thank you.